aspetta, ti sto scegliendo la screen.
Oh, Jesus.
Okay, so hi, Mr. Embarra, we're Isabella, Simona, Jaco, gas laws.
Okay, so I'm going to start with Boyle's law history. This law was named after chemist and physicist Robert Boyle. He published this law in 1662, and his purpose was to show that the volume of air trapped by a liquid in the closed shorted limb of a J-shaped tube decreased in exact portion of the pressure produced by the liquid in the long part of the tube. Okay, so the definition, as you can see, is that a law stating that the pressure of a given mass of an ideal gas is inversely proportional to its volume at a constant temperature. Okay, so here you can see the formula. I'm going to explain it to you. The P1 is equal to the first pressure, V1 is the first volume, and P2 is the second pressure, and V2 is the second volume. Okay, so here's the graph. So the graph of V against 1P, as you can see, is a straight line to the origin. What this means is that the measured volume is inversely proportional to the pressure. So a real example that I found was that you can observe in real life that when you fill a bike's tire with air, so when you pump air into a tire, the gas molecules inside the tire get compressed and packed closer together. At the same time, its pressure decreases. So here's the first sample problem. So a gas occupies 12.3 liters at a pressure of 40, no, okay. What is the volume when the pressure is increased to 16, okay. So you can see that with this problem, the formula that I showed before, he used it correctly, and he found the correct answer. And the same happens in both of the next problems that he uses the formula. So if you can please pass the slides so that the audience can see the next problem. Excuse me. Okay, so there's the next problem. You can see that he used the formula. And the next one, please. There you go. Fantastic. Proceed.
Okay, so Charles.
Google Play.
Why is it loading? Sorry.
Mr. House Quarantine going.
So this law was created by Jacques Charles. Okay, like this. It was created by Jacques Charles, and he discovered this by creating a manned balloon flight using his hydrogen gas produced through a chemical reaction. But he did not cool it down before charging it into the balloon. So it deflated, and then he realized that the volume of a fixed mass of a gas is directly proportional to the temperature. So it basically states that gases expand when heated and shrink when cooled. And this is a formula of the law, that is the volume over the temperature before the change equals the volume divided by the temperature after the change, and you always have to use it in Kelvin temperature. And this is a direct relationship between temperature and volume. So the more temperature, the more volume. So here is the volume. A real life example is a hot air balloon that works accordingly to the Charles law. And like there's a burner inside the hot air balloon, so the gas expands. So when the air inside the balloon expands, it becomes less dense and provides the lift for the hot air balloon. Okay, so in order to solve this, so a problem would be a balloon takes up to 625 liters at 0 degrees. If it's heated up to 80 degrees, what will its new volume be? So here you have the volume 1 over temperature 1 and volume 2 over temperature 2. So in order to solve this, first of all, you have to change the temperature to kelvins, which is at 273 to the
Ya lo descargué. Ay, sorry.
to the temperatures. And then you cross multiply, so this would be 308 liters is the second volume. Same with example 2, you take the first temperature and the second temperature and you convert it to kelvins and then cross multiply. And here is an example of it changed, like the temperature went down, but so you cross multiply like the numbers reversed.
Okay, so Gay-Lussac's law. So this law was invented by the French chemist Joseph Gay-Lussac, who discovered the relationship between the pressure of a gas and its absolute temperature. So this law states that the pressure of a given mass of gas varies directly with the absolute temperature of the gas when the volume is kept constant. So this law is very similar to Charles' law, with the only difference is that while his experiment he used a rigid container while Charles used a flexible container.
Debe ser por eso.
So the relationship and formula, basically the relationship is that the pressure of a given mass of gas varies directly with the absolute temperature of the gas when the volume is kept constant. So here we can see the formula. So the starting pressure, the final temperature, and the final pressure and starting temperature. So in this graph, we can more clearly see the relationship. So as the temperature increases, the pressure does as well. So if, for example, I were to increase the temperature in Kelvin by 2 times, the pressure will also increase by 2 times. So this means that the relation between pressure and temperature is directly proportional while in gas. So a real life example I found was a pressure cooker, as the water that vaporizes inside it and the steam that is released through the valve maintains the pressure inside of the cooker. But if the valve malfunctions and the heat flow is not interrupted, the pressure inside the cooker escalates. And this means that the amount of gas increases and the temperature too, increasing the gas. So here's an example to understand. We can see how here he uses the equation and the problem to get the result. So he first finds each variable. So he finds the initial gas, 4.5 atm, the Celsius that he has to convert to Kelvin. So he adds 273 to the original temperature, and then he just inputs the equation and he gets the atmosphere. So here we can see a for example problem. As I said in the last problem, he just gets the first variables and changes the Celsius to Kelvins, does the thing and gets the new answer. And it's basically a very simple process we can see in the next problem. So yes, P1 divided T1 equals P2 divided T2. So he just inputs everything in and you get the 1.5 atmosphere. And the final problem that, as the others, he just inputs the values to the equation and changes Celsius to Kelvin if needed by adding 273. And yes, that's it.
Thank you, mister.
Thank you, mister.